ambiguous case of the law of sines. Today we're going to talk about case 2, which is when we have two sides and one angle that is not included between the two sides, which is also known as side-side angle. If we're given the lengths of two sides and the angle opposite one of them, then 0, 1, or 2 triangles may exist. Here's a chart to show the possibilities of the different things that we could have whenever we're given an angle and two sides. If the angle that we're given is an acute angle, and it looks like the sketch that we have in this first row, here we have an angle and two sides where the angle is not included. Well, if you'll notice, side A, or the side that's opposite angle A, it's possible that it's too short and it doesn't reach the third side. So if that is the case, then no triangle would exist. Another possibility when our angle is acute is that the side that's across from the angle is the same length as the height of the triangle. And if that is the case, then only one triangle can exist. Another possibility when the angle that we're given is acute, if the side that we're given is longer, if A is longer than side B, then only one triangle can exist. Now the fourth case, if we have an acute triangle, here we have our angle, our side, and then the other side could be this or this. Now they're the same length, but it could make two different triangles. So I'm going to try to show you with a little bit different diagram how this works. If we're given an angle, a side, and then that side that you see there that's red, in this case we see that there is one triangle. But it's also possible with that same length of a side, that red side, that same length could create a different triangle. So with these three parts, an angle and those two sides, we could either have this small triangle or this big triangle. So that gives us two possible triangles that could exist. Now, if our angle is obtuse, meaning that it's greater than 90 degrees, if we're given an angle, that angle and two sides, again, if that side, the side that's across from the angle, if it's too short to reach the third side, then no triangles would exist. And the other possibility, if it's obtuse, is that one triangle exists. So there's not a possibility of having two triangles when your angle is obtuse. Alright, so this little chart here helps us to know when we have no solution, one solution, or two solutions. If you'll notice, we compare side A with B times sine of A for several of these. And so when we're comparing these, it's not necessarily going to be labeled side A or angle A in your problem that you're working out. Just know that we're always going to pair the angle, so sine of the angle times the side that's touching that angle. And we're going to compare it with the side that's opposite that angle. So what I mean by that, if you're given a triangle and it's labeled as, say, this is C, this is A, and this is side C. Okay, so then we would be comparing C with A times the sine of C. Okay, and so we would want to know if C is less than, equal to, or greater than A sine of C. Okay, So it doesn't necessarily have to be labeled the labels that are in this chart. All right, so if we compare A with B sine of A, if A is less than B sine of A, then there's no solution. If A is equal to B sine of A, there's one solution. And if A is greater than B sine of A, then there's two solutions. Or if side A is greater than or equal to side B, right here, then there's one solution. So I would check for that first, since that's the easiest thing to check for. We don't have to plug in B sine of A into our calculator. We can just look at the two sides and compare them. And if A is greater than or equal to B, we know that we only have one solution. And then, of course, if our angle is obtuse, then we could either have no solution or one solution. And for those, we just compare side A and side B. All right, so here's our first example. Solve triangle ABC if angle B is 55 degrees, 40 minutes. Side B is 8.94 meters, and side A is 25.1 meters. Okay, so like I said, the first thing we would want to do is just compare the two sides. Now, I see here that A is greater than B, but this is different than what's in the chart because remember, in the chart, my angle is angle A, all right? So let's pretend like that's angle A, and if that's the case, then this would be side A, and this would be side B, okay? So if we're looking at what it is in the chart, side B is greater than side A. Okay, so let's go back to the chart. This says side A is greater or equal to side B. Okay, so that's not going to help us there, okay, because B is greater than side A. So let's go on. Let's use another thing. Okay, so now we're going to compare A with B sine of A. Okay, so we're comparing A, which in this case is B. Okay, so we're going to compare 8.94. We're going to compare it with B sine of A, which in this case would be 25.1 times the sine of 55 degrees, 40 minutes. Okay, so I need to put 25.1 sine of 55 degrees, 40 minutes into my calculator. And when I do that, I get 20.7, or we can even do 7.4. Okay, and then we have 8.94. Okay, so the 8.94, of course, is less than 20.74. Okay, so let's look back at the chart. All right, here is the less than. My side that was across from the angle is less than the other side times the sine of the angle. So that means there's no solution. All right, so because my side that was across from the angle is less than the other side times the sine of the angle, there's no solution to the triangle. All right, let's look at another triangle. Okay, so again, the first thing we're going to do is just compare side A and side B. And this time they're named like the chart is because my angle is angle A. All right, so as long as your angle is angle A, then it's pretty much like the chart. Okay, so I have angle A, and this is side A. So, but again, first of all, let's compare the two sides. All right, so if we compare the two sides, if side A is greater than or equal to side B, then we're going to have one solution. All right, is side A greater than or equal to side B? No. So that means, well, that doesn't mean that we don't have one solution. If A is equal to B sine of A, then we could also have one solution. But if A was greater than or equal to B, we would know that there's only one solution, but it's not that easy in this problem. So now let's compare A and B sine of A. Okay, so A is 22.8, and then B sine of A, that would be 24.9 sine of 55.3. Okay, so if I put that 24.9 sine of 55.3 in my calculator, I get for this 20.47. So that means side A is greater than B sine of A. Okay, so right here in the chart, side A is greater than B sine of A. So that means we're going to have two solutions for this triangle. Okay, so we know we're going to have two solutions for the triangle, so let's solve the first triangle. And we solve it just like we've been solving the triangle so far with the law of sines. Okay, so I am going to be looking for the sine of B first. So I'm going to put that on top here, sine of B. And that's going to be over the side of B. And then that's equal to, we're going to create the proportion with sine of A over side A. Okay, so when I cross multiply that, remember I'm just multiplying this right here. And then I'm going to have to take sine inverse to get this sine off of B. Okay, so this is going to equal B, or B is going to equal sine inverse of 24.9 sine of 55.3 over 22.8. Okay, so that gives me angle B is 63.8879. So let's just say 63.9 degrees, because they rounded this to the 10th place, so we'll do the same. Okay, so that is my side B. Okay, so we're still missing side C and angle C. Well, to find, let me write this up here. All right, so this is what we're trying to find, angle B, angle C, and side C. So we found angle B. Now to find angle C, all we have to do is subtract angle B and angle A from 180 degrees. And when I do that, I get that angle C is 60.8 degrees. All right, so now to find side C, I'm going to use the law of sines again. So I'm going to still use angle A and side A as part of my proportion, since that was given to me. And I'm looking for side C, so I'm going to put that on top. So I'm looking for C, and that's over the sine of C, which is 60.8. And that's equal to side A, which is 22.8, over the sine of A, which is 55.3. Okay, so I'm going to cross multiply. And so all I have to do is cross multiply here. I don't have to take the sine inverse or anything like that, because I'm looking for a side. Okay, so if I cross multiply that, then I get C is equal to, and I have the 22.8 sine of 60.8 over the sine of 55.3. And I'm going to put that in my calculator. And when I do, I get 24.2, and that would be 24.2 feet. Okay, so I have 24.2. Okay, so I have found, or I have solved one of the two triangles. So now I need to solve for the second triangle. Okay, so let's imagine, for example, that one of these is our triangle down here. Well, if we found, say if we were given this angle, this side, and then the red side. Okay, so if we had that big triangle there, okay, and now we're trying to find the second triangle, which is the smaller triangle in here, this part right here. Okay, so if we're trying to find that triangle, notice that our angle C, which would be right here, not angle C, angle B. So that's our angle B right there. Well, our other angle B that would make our other triangle would be this right here. Well, these two angles, this angle and this angle, are supplementary to each other, meaning that they add up to be 180 degrees. Because this in here would be a right triangle, or an isosceles triangle, because these two angles would be the same. So that means that these two have to add up to be 180 degrees. Okay, so in order to find our second triangle, we're going to take our angle B and subtract it from 180 degrees, because we know that the other angle B that makes up our second triangle has to be supplementary to that angle. Now, our second triangle, we know, is going to have the same given parts, but we're going to say that our second triangle is our prime triangle, okay? So this is a prime. That just means another angle. Okay, so A prime, or the part of our second triangle, is 55.3 degrees. Side A prime is 22.8 feet. Side B prime is 24.9 feet. And then now our angle B prime, we're going to take our other angle B and we're going to subtract that from 180 degrees, and we get 116.1 degrees. So I'm going to tell you a little shortcut for this, for the solving the different triangles. You know, we were looking at that chart to tell how many triangles there were. You don't really have to look ahead to see how many triangles there are going to be. You can solve for the first triangle. If it doesn't work out, like this one that we had before, there'd be no triangle. When you try to work it out, if you went ahead and tried to do the law of sines, when you plug it into your calculator, you're going to get that there's no solution when you try to find the sine inverse of that first angle. So say, for example, if you set it up, if we tried to use the law of sines like this, and then we took the sine inverse of both sides, so we're looking for the sine of A, or angle A, so we set it up as sine of A over side of A is equal to sine of B over side of B. We took the sine inverse of both sides. If you put this in your calculator, you're going to get that there's a domain error. It's not going to work. So we didn't do that. We looked at that chart, this chart, to find out, and we found out by doing A is less than B sine of A, we found out that there was no solution like that. But if you didn't even look at this chart and you just tried to work it out, it wouldn't work out. There's not a triangle. So when we have a case like this, if you work it out and you get a triangle, well, that's one triangle. Well, then if you take the angle that you find, So, of course, we're given an angle and two sides. So then that next angle, the very next angle that you find, if you subtract it from 180 degrees and it doesn't work, say if you, I'm sorry, not if you just subtract it from 180 degrees. Of course, you can subtract it from 180 degrees and you'll get something. But when you subtract it from 180 degrees, whatever you get, you have to be able to add it back to that angle A, and that together has got to be less than 180 degrees. If not, then of course it's not going to work because you still need an angle C. So if you add your B prime and your A prime together and it's 180 degrees or more, then of course you don't have a second triangle because there's not enough left to make that third angle. So we know that there's supposed to be two triangles here, so this should work, but let's add this up and see. If I add up 116.1 plus 55.3, that gives me 171.4, which is less than 180 degrees. So we know that we can have a third triangle. Okay, so let's, if I subtract that 171 from 180, 171.4, sorry, then I get that my angle C is 8.6 degrees. Okay, so all that's left, that's C prime, sorry, all that's left is to find side C prime. So to do that, we're going to use the law of sines. Again, I always like to use what we're given, so since we were given sine of A, or angle A and side A, I'm going to use that in my proportion. And I'm looking for side C. Alright, so side C over sine of C, which is 8.6, is equal to side A, or A prime, over the sine of A prime, which is 55.3 degrees. Okay, so then I cross multiply this right here, and that gives me that C is 4.1 feet. And so now we have found both, we have solved both triangles. Alright, here's our last example. We're given angle A, side A, and side C. So this would be the same as if we were given side B. So we're using, if we were going to try to compare the two, we would do C sine of A and compare that to side A. But let's not even look at the chart now. Let's go ahead and just compare, or go ahead and solve the first triangle. Of course, if there's no solution, then we'll stop. If there's one solution, then we're going to look to see if there's possibly a second triangle. Okay, so to solve my first triangle, I'm going to first look for angle C. So sine of C over side C, which is 7.2, is equal to sine of A over side A. Okay, so remember we cross multiply, and then we have to take the sine inverse of both sides. So C is going to equal sine inverse of 7.2 sine of 43.5 over 10.7. So I get that angle C is 27.6 degrees. Okay, so then I need to find side or angle B. Okay, and of course we find angle B by subtracting angle C and angle A from 180 degrees. Okay, so when I do that, I get that angle B is 108.9 degrees. And now I want to find, excuse me, side B. Okay, so we have these two here. And the stuff that we're given. And we just need to find side B. Okay, so side B over the sine of B is equal to, and again I'm going to use what I'm given, and I cross multiply this. So I get that side B is 14.7 inches. Okay, so I have solved one of my triangles. Now let's see if there is a second triangle. Okay, so to see if there's a second triangle, I take that first angle that I found. Okay, so side angle C. Okay, so I'm going to take that and subtract it from 180 degrees. All right, so if I subtract 27.6 from 180, that would be my C prime. That's 152.4. Okay, so if this is my C prime, or the angle C for my other triangle, I have to use the same given parts, that part up there, for my other triangle. So that means angle A would be 43.5 degrees. Well, if I add 43.5 degrees to the 152.4, I get 195.9 degrees. Well, that's more than 180 degrees, so of course we don't have enough angle left for an angle B. So that means there is no second triangle. Now, we could have figured this out. Can't spell triangle. We could have figured this out by using that chart at the beginning, or you can do it this way and just test it to see. Either way, we know that there's only one triangle here.